Good evening. So in today's class we'll be talking about the addition reactions of benzene given in class 11 chapter Hydrocarbons. So let us begin. Now before we move on to the reactions in details, let us first understand what are addition reactions. These are those reactions in which we add something and no removal of anything. So in substitution reactions we were adding something in place of another thing. In addition we'll just add but we'll not remove anything. Okay, there are three addition reactions which are shown by benzene. The first is that when I have a benzene ring like this and I will add hydrogen molecules. How many? 3 hydrogen molecules. That means total hydrogens how much? 3 2s are 6 hydrogens under a nickel catalyst and in heat, because I require a lot of heats for making and breaking of bonds. Okay, so high temperature or a pressure I require for this, and I will form cyclohexane. Okay, let's understand this. Benzene is having the formula C6H6. Cyclohexane has formula hexane minus 2 hydrogen. Hexane means C6H14 minus 2 C6H12 is the formula. All cyclo compounds have the formula of minus 2 hydrogens of their original parent hydrocarbon. Okay, so that means I have to add 6 hydrogens plus 6 hydrogen, so I will get cyclohexane. That same thing I have done. In presence of a catalyst to increase the rate of reaction with nickel catalyst is the best catalyst of hydrogenation. Okay, and I have used heat. Now why do I need heat for this reaction? Heat will break the bonds of the benzene and make it, because this is unsaturated because of double bond, so this has pi bonds in it, but this has only sigma bonds, so I have to break the pi bonds, for which I require heat or high pressure, but heat is the better condition. And this reaction is called the hydrogenation reaction of benzene. Okay, to give hydrogen, add hydrogen. Moving to the next category of reaction, the next category is another kind of chlorination. Okay, in which the benzene ring, now this is not electrophilic substitution of chlorine, in which I was removing a hydrogen to add chlorine, but here I will not remove any hydrogen. I am simply adding 6 chlorine atoms to it under ultraviolet light, which I write UV. Okay, in high temperature, approximately 500 Kelvin is a good high temperature, and I am getting something called this kind of a structure. 6 chlorine, each chlorine at 1 atom. Okay, I am getting this structure, which is called benzene hexachloride, also called BHC is the structure, benzene hexachloride. Okay, benzene hexachloride also has another name called gamexane. Okay, is another name for benzene hexachloride. Now let us try to understand this reaction. Here I have not removed hydrogen. If you will see, it first appears that we have removed the hydrogen and added the chlorine, but I have not, because you can see I have broken these double bonds. If I had double bond, I had only 2 hydrogens per carbon atom, but if I have broken this double bond, I have 3 hydrogens per carbon atom, which is retaining the hydrogen number plus this chlorine as well. So hydrogens are retained, all H are retained, because when I was doing electrophilic substitution of benzene, I was adding the chlorine by removing hydrogen from the double bond, but here the bonds have been single. That means one bond is gone, one hydrogen retained, and chlorine is come in place of the double bond. So hydrogens are retained, so this is not a substitution, this is an addition in which I have added the chlorine by retaining the hydrogen. Again, high temperature required for breaking of bond, which was the case here as well. The third one is combustion. Now when I talk about combustion means heating a substance in presence of O2, oxygen, which will give out energy in the form of heat and light. That is the meaning of combustion, when I heat any substance in presence of oxygen to give out energy in the form of heat and light plus the products of the substance. This is the combustion reaction. Now benzene also will undergo the combustion reaction. So I'll give this equation. Benzene C6H6 will also undergo this combustion reaction okay, by getting oxygen to give carbon dioxide, water and energy. We don't generally write the energy, but energy is given out in a huge way. Okay. Carbon dioxide and water are the major products of combustion. All combustion reactions involving any kind of hydrocarbon, it has to give a carbon dioxide and a water molecule, water in the vapor state. Okay. Now, for balancing this equation, to get the balance, this equation is not balanced. We will use a very simple rule. Okay. So I'll just write the rule first and then we understand it. Okay. If we have CXHY in the parent hydrocarbon, then the number of oxygen will be X plus Y by 4. We have to remember this rule. And the number of carbon dioxide will be X again. And the number of water will be Y by 2. Now let's understand. If the parent hydrocarbon which is undergoing combustion has X number of carbons and Y number of hydrogen, then the number of oxygens will be X plus Y by 4. Okay. So let's understand. Now in this case, in case of benzene, I have C6H6. That means X is also 6 number of carbon, Y is also 6. Okay. That means oxygen will be 6 plus 6 by 4. I take the LCM. 24 plus 6 by 4, which is 30 by 4, which is 15 by 2. So I write 15 by 2 oxygen. Fine. Now for water, carbon dioxide, it is X. X means 6, so I have 6 carbon dioxides. Fine, because here X is equal to 6. Water is Y by 2. Water is Y by 2. Now what is Y? Y is equal to 6, so Y by 2 is equal to 3. So I have 3 water molecules which are produced in this reaction. One more thing to understand easily is that carbon, we are not doing anything to the carbon. This carbon is changing to carbon dioxide. So this has 6 carbons, so this will automatically have 6 carbons. That is one thing for carbon, but we'll follow this rule. If in the parent hydrocarbon, okay, has X hydrogens and X carbons and Y number of hydrogens, then the number of oxygen will be X plus Y by 4. Number of carbon dioxide will be X only because carbon is not altered, and number of water is Y by 2 is the concept to be used. And apart from that, energy in the form of heat and light will always be produced in combustion. That's why for using fuels, we are using the combustion reaction. Okay. So for benzene also, we'll heat it in presence of oxygen. We'll get carbon dioxide, water and energy in form of heat and light. These are the major product. This is the energy product of it. Fine. And any combustion reaction will give carbon dioxide and water in all situations. Okay. So with this, we are done with the addition reaction. So again, I'll give you a quick recap of the addition reactions. We had the first reaction of hydrogenation, in which we have given hydrogen in presence of nickel catalyst and heat to transfer benzene to cyclohexane. Next one was, I am transferring benzene into benzene hexachloride by adding ultraviolet light and chlorine atoms. Hexachloride benzene is also called gamexane. So you can be asked a question to convert benzene to gamexane or to write the formation of gamexane. So it's the same thing. And the last one was the combustion, where the benzene ring in presence of oxygen gave carbon dioxide, water and heat and light energy. Okay. It is always better that we mention energy in the combustion reaction. It makes the equation complete. Fine. So with this we close the class. Thank you. Please like, share and subscribe.